Hello, everyone. Thank you, Marco. It's a pleasure to be here. My talk today is going to be about data management in CompBioMed, especially what we did in CompBioMed 1 and what are some potential plans or things to do to move more towards fair data. A short introduction about where I come from. I come from SURFsara. Well, my colleague already introduced SURFsara in the morning, Valerio. But just to say, SURF is a collaborative organization in the Netherlands for ICT, and we are having more than 100 research and education institutes as our stakeholders. We started in 1971 as SARA. In 2013, we merged with two other providers in the field of ICT and network as SURFsara. And to even confuse you more, as of 2020 in summer, we are in the process of a reorganization to become one SURF. So this is just the history and where we are getting to. And our message is that we are going to drive innovation together. The fields that we contribute to in the Netherlands is mainly education, research, and cooperative facilities like networking. And the focus, I think, for the projects that we work with is mainly the research, where we provide big HPC systems for doing research and also stimulating open science. Well, we have the Dutch National Supercomputer, which was introduced this morning as well. I'm not going to tell about it too much. This is the big tower, is the data center in front of our office where our system lies on. So SURF is not only about big systems. We also contribute to consultancy and trainings we do for researchers and education and our services. And we do knowledge exchange. And beside all these, we have a data services unit at SURF, which tries to provide or facilitate services that can facilitate you during the research data life cycle, as was also explained in the previous talk about the data life cycle. You start with a plan, you acquire or gather data, you process those data, then you want to analyze it in some HPC facility, high performance computing. And once you're done with your analysis, you want to preserve the data, share it with others, give access, and eventually reuse it. And the services that we offer at SURF Data Unit, well, we try to cover all these steps. Of course, there is no single service that can facilitate all the steps, but with a combination of one or two or more services, we can facilitate that. We have the data ingest service and all files under service, which is the data ingest service is a service that actually, if you want, you gather data on a hard disk, for example, or you have large amount of data on disks and you want to ingest it into the HPC system. We have a service that can do it in parallel, and which might take years if you want to do it through internet. We also have a file sender service, which is for transferring data, which doesn't simply fit to attach to an email. Then we have other services like Research Drive and Surf Drive, which are services for sharing data. They are both based on OwnCloud and in the backend based on Object Store. And it's, as I said, mainly for sharing data and working with active data. We also have a data archive service, which is based on tape, and it's meant for long-term preservation of the data. To mention that this the data archive service is tightly coupled with our compute facilities, Lisa and Cartesius, for example, through NFS mount. So there is a good connection, fast connection between them. And we have the PID service for handing out handles or PIDs for the data. And also a data repository service, which was mentioned in previous talk. It's as was mentioned, there are a lot of data repositories out there by university libraries, but the focus of SURF data repository is for publishing large data. So if we are talking about 100 terabytes of data, it doesn't make sense to transfer all these data to some other repository, and the SURF data repository is meant for publishing large data. So it's basically a layer connected to the tape, to the data archive, which is based on tape, and it's developed as such that it's aware of the status of the data, if it is online or offline, and enriches basically the data with metadata. This slide is, well, again, about the services that we have. So in the y-axis, you see the scalability. If you with the data, amount of data that you have, and the x-axis, you see different steps that are involved in your data lifecycle or research lifecycle. As you see, well, the research drive service, which is based on disk, is mainly for processing online data, and is meant for active data, and is meant for also for sharing data, whereas it may not be suited for large amount of data, whereas we have the archive, which you can and the object store, which you can scale the data you store up to petabytes of data. We also have a so-called IROT services, an IROT scale-out service, and an IROT hosting service, which are fairly new. They are in the production phase, but still it's as of this year. So the IROT scale-out services, well, mainly connected to tape, and well, if you want to scale the storage at your institute, you can use this service to scale it. And then also the persistent identifier service that we offer. So this is basically an overview of the services that we offer at SURF. We are also involved in several projects, national and international ones, mainly related to the data, like the European Open Science Cloud, the SURFsara project, EU.dot and EU.dot CDI. We have been working with the communities also like CompBioMed, Odyssey, Clarin, and well, others within our units. And working with all these communities, we have realized that there are some common requirements for doing research, data requirements among all these communities that mainly work with high performance computing, which is efficient access to data and data sharing, especially intensive data sharing and transfer, and also nowadays with all this awareness about data privacy and data confidentiality, restricted data sharing and transfer is a requirement that research that include DNA or private or sensitive data would need. Preserving research data has been always a requirement. Where do you store the data that is being backed up and archived for a long time, and also for large data, and if it needs to be synchronized over distributed places or not, and data provenance, where the data has come from, and well, making data accessible and findable is also something that is becoming more and more needed, especially with the FAIR principles becoming more and more popular, to make data accessible to other communities by usage of persistent identifiers, for example, or publish the data with specific domain-specific metadata so that it can be found and reused, and also linking the data or published data to processed or raw data. So these requirements, I think we as CompBioMed community can also see many of these requirements or challenges in the work that researchers are doing in CompBioMed community. Well, I'm not explaining this. I think everybody has been familiar by it now. The FAIR principles, which stands for findable, accessible, interoperable, and reusable data. And as was pointed out, this reusability, I think, is a very important part, because if you are able to reuse it, you have been able to find and access. And the good news is that, well, to meet those requirements or to come up with solutions for that, we do not need to start from scratch or reinvent the wheel. There has been projects that have been working in these areas, like EUDAT and EOSC, for example. And EUDAT in particular, in EUDAT CDI, which is a continuation of EUDAT project, offer a so-called B2 services service suite, which are a couple of services that facilitates data management and data, well, all the things that is needed for fair data. Let's say. So, well, just to name, B2 Access, B2 Drop is, for example, a Dropbox-like service that can be used and is available to all the researchers. Citizen researchers, let's say. The B2 Safe service, which I'll and B2 Share, which I'll get to later. B2 Find was also mentioned. B2 Handle, which is basically the persistent identifier service. So this slide also shows the interconnectivity sort of about, among these services that EUDAT offers. I'm not going to go through the details, but just to show you that the different layers, like user management, data preservation, data access and sharing, and data discovery, where B2 Find, for example, which is basically a portal for finding data, and B2 Share, which is the data repository, B2 Drop also, which can be used for sharing data. You can see that for different, for data or for metadata, for example, how the flow would be. So if, for example, you have some data that is stored in B2 Safe, you can publish the metadata in B2 Share, and then this metadata can be findable or harvestable through B2 Find. And the same for data, for example. If you have some data in your B2 Drop stored, you can, this service is integrated with B2 Share, and you can, through that system, publish that data in the data repository. So there is a lot to say about this graph, but I just wanted to show you an overall how all these services are interconnected with each other. So now moving back to what we did in CompBioMed. So as I said, we tried to use the EUDAT services to see how we can address this requirement of large data transfer and replication. So we started with a use case, which we call the workflow that uses Alya Application, where basically researcher the data was generated in ESRF in lab in France, and then transferred to the Barcelona Supercomputing Center. There, the researcher did some pre-processing on the data, and then run the simulations using the Alya application on the supercomputer at Barcelona. And the idea was that if the same data could be available in other HPC centers, because Alya application is also installed on EPCC and in the UK, and also, excuse me, in SURFsara, the Alya application is installed. So if we can replicate that data to those HPC centers, that we can sort of scale up the compute power in running simulations, and also make this data accessible to other researchers who are working close to those HPC centers. So then we used the EU.B2Safe service to replicate data to the other two HPC centers. A little bit more about what B2Safe service is. It's basically provides an abstraction layer, which is abstraction layer over the underlying storage systems, let's say. It's based on IROTS, which is a middleware that facilitates that, and one of the strong features of this and also IROTS is the definition of metadata, as was pointed out earlier in earlier talks, that you can define metadata and enrich your data with metadata with
Sorry,
IROTS.
Narges.
Yes.
5 minutes left.
Oh, then I have to be quick. So we basically use B2Safe to replicate data. This is, well, an overview of what we did. We basically installed B2Safe instances in these 3 HPC centers, and we federated them, and we basically built a network of these federated network of these B2Safe instances. And then we tested a scenario where we replicated some test data from BSC at SURFsara and to EPCC. We did that with the test data. With the real data that we were going to replicate was 24 terabytes. Another important thing to mention is that while doing this replication, the data was also getting a persistent identifier through the whole process of the replication, and it facilitated the large data transfer and brought the data close to compute to scale up the compute power. So we tested this scenario. This is what we did in CompBioMed 1, and what we would like to continue in CompBioMed 2 as for this pilot is that, well, we have LRZ, which I'm very happy to hear that they are also experimenting with IROTS and B2Safe. So we can extend this network of B2Safe nodes with the new HPC center LRZ. Actually do it for the real 24 terabyte of data, which requires allocation of 24 terabyte storage per HPC center for that. And also testing other scenarios, like what if the data is being replicated from BSC to EPCC, and there through an automated process with an IROTS rule be transferred to SURFsara. And as I said before, the B2Safe instance at SURFsara is connected to the tape. So whatever data that comes into B2Safe will land on tape for long-term preservation. So in this case, SURFsara is also a sort of archiving node in the whole process. Then, well, B2Share, maybe I can go very quick, is the data repository of EU that where you can publish your data. And what we did in CompBioMed 1 was we asked the B2Share central instance to add CompBioMed as a community. Right now, we are using the generic metadata schema for that. But the idea is that we come up with a community-specific metadata schema, so that if you as a researcher within the community want to publish some data related to a publication or whatever related to the community, you can go to this repository, and it's let's say free, it doesn't cost, and you can publish your data. Of course, there are some limits in the size of data that you can publish, but usually for publication data it should work. And this brings me, well, this is my last slide, which brings me back to the title of my talk, which is moving towards for data in CompBioMed. The graph that you see here is, let's say, a concept or a future workflow where we can say if we are able to say we support a fair data lifecycle, which is basically data being generated here in a lab, transformed to an HPC center, replicated to other HPC centers for scaling up and also for preserving data and running simulations in those HPC centers. And once the simulations are done, the output can be stored in a data repository that can be used by others or the wider community later. This is, I would say, a workflow that would support a fair data lifecycle. And so this brings me to the end of my talk. Thank you for your attention.
Thank you very much, Narges. We have time for some questions. Any question for Narges? Otherwise, I have one question. It's more to get your opinion. So I think that this idea of workflows to replicate data is essential for projects like CompBioMed, and especially in the view of more machine learning workflows on HPC systems as well. And we worked a lot with the EUDAT tools to have these workflows set up. Do you have any recommendation or maybe points that we can report to EUDAT people on the deployment of the tools, or the difficulties that we faced trying to set up this kind of workflow using EUDAT tools like B2Share and B2Safe? Do you have anything?
Yeah, Marco, this is a very good point, because what I just showed, like this network of B2Safe, it's as you noticed when we were doing the work, it's not a, let's say, easy thing to establish. It requires some effort and commitment from both community side and also the service provider, let's say. So it takes quite some effort from the community to set this up, to set this network, or to set such a platform in place. But once it is there, it is like now that we have this network of B2Safe, it is not that much of an effort to use it for other use cases. So once we have it established, you can once these HPC centers are federated and technically is there, it can be used for any project or any research to transfer data between them. So I agree that it takes effort and takes commitment to set it up, but once it's there and once it's operational, it can be, I think, be used for good for many projects. I'm also partly involved in the EUDAT and EOSC side, so they are also aware of these challenges that communities face in setting up such platforms, and so far they have provided great support for doing that, I would say. So yeah, I don't know if this answered your question or not, but
Yeah, that was more or less an overview. Yeah, it's good that we had experience with this and we are in close contact, and I hope this will help in deploying this kind of tools also in other systems, as you said, extending the workflow with the LRZ and other sites. So again, thank you, Narges. It answered my question.
Yeah.
Any other question for Narges?